Grantham University Capstone project. Student ID number G000817778. This is the gasless generator. Start out with, the purpose of this was to be able to generate electricity and be self-sustaining after startup from an initial 12-volt power source. Initially, through testing and modification, an automobile alternator worked great. I did run into an issue. That's currently why this will not be able to be a full demonstration, because I've actually burned up this motor, which is the main drive motor for the entire system. This piece right here is the generator just for the load or the generation side. The other side, this is going to be the load side. So you would put whatever size alternator, 80 amp, 100 amp, 150 amp, in comparison to the inverter. Okay, coming over. So I have my various circuitry, a power source feeding in at the moment just for demonstration. Okay, so starting at the top, these would be normally connected to the generator side, which would actually turn 3-phase back into DC, which would then go back into this and come off the battery. Therefore, the battery would be no longer needed. So from this, the way I'm controlling this is through a 555 timer circuit made specifically to control a gradual ramp to this brushless, sensorless control, self-powered, so it does not rely on any other power throughout this rest of the circuitry other than the power supply board. This board takes in the main voltage generated from the DC side here. Once it's filtered down, converts it down to 5 volts, 12 volts. This right here is for the actual stator, because with the alternator modification, what has to be done due to it not having a permanent magnet, you actually give it an electrical current or voltage to generate magnetism, therefore then making it a motor once you energize that coil and energize the 3-phase. So 3-phase powering the stator, DC power coming from the second side of the circuit, which is currently, you can't even see it, but I use the LED for demonstration. I also have the sawtooth wave, and what that's doing is limiting my current going through, switching this on and off rapidly, getting my voltage, my 24 volts to power this core, going over to the back to the center, which would actually come into here. One side would be connected straight to the 24 volt DC converter. The other side would be coming off the other end of the MOSFET in, which is being switched rapidly in order to reduce the current, therefore increasing the RPMs. Overall, there's lots of lessons to be learned here. I have yet to disassemble this motor. This motor is my single point of failure at the moment. It's pretty much halted this project in its tracks until I figure out what's going on with it or why. It's a good lesson learned. Other than that, another lesson learned would be, given the allotted time, I believe I may have bitten off more than I could chew. Rather large project. So that is the Capstone gasless generator project for student number G00081778.